Is it okay? Okay, I'm Lentin Joseph. I'm coming from Kerala. Actually, today I like to present some application of Python in robotics. So, actually, I was working on a company called Robotics. Now I'm planning to start a new company. So, this is my blog, tech blog. Then I have experience in robotics for the last 3 years and Python for last 5 years. And this is my website. So this is the plan. I'm going to first I'm going to give some introduction to robotics, basic definitions. Then we are going to design a robot. The purpose of this robot, the application of this robot is it will track ball, colored ball, or any colored objects. And then I will explain the blocks. Block means the components. Then the technology. Then where we use Python in this robot. Then finally, I like to do some demos using this robot if it works. Okay, so we can start. So basically, what is robotics and what do you mean by a robot? Then type of robot. So how many of you interested in robotics? Just raise your hands. Okay, that's great. So I'm giving just a introduction. Just a definition. This is robotics. Robotics deals with design, construction, operation and application of robots. Very simple. Then a robot is simply a machine or a program. It's built for doing real world function. It's very simple. Then these are the main type of robot. There are 3 type of robot. First is manipulators. It's also called robotic arm, like our hand. So it's mainly used for industries like for manufacturing automobiles, for welding. This is a industrial robot mainly for welding. Yeah, that is the main purpose of manipulators. Next is mobile robots. From the name itself, we will get it can move. It has wheels. So mobile robot means it has wheels, so it can move. And there are a lot of examples for mobile robots. There are a lot of rovers exist. That's all belonging to this category. Next is hybrid robots. Hybrid robot is a combination of manipulators and mobile robots. It has manipulation, like it has robotic arms. Then it has it has wheels. Maybe it may be wheels or it may be legs. This is Asimov. You may know about it. It is a hybrid robot because it has manipulation and it has mobility. So this is just about robotics and what is robots and type of robots. Just finished. Then we are starting to design this robot. So I like to show the 3D model of this robot that we are going to build for better understanding. I have SketchUp here. Actually, it is Google SketchUp. This is mainly running on Windows, but I install using Wine. So this is our robot. See. So this is a 3D model of the robot. So I marked all parts and it looks like this. But there are some parts missing. This is the robot that we are going to build. So I will explain each parts. Okay. First, what this robot can do? Just I said, it can track colored objects. Colored object. It has a webcam and there is a ball. So it can track. I will show the demo later. it can track objects, and there are some add-ons, but I didn't do in this hardware. It can respond to human voice commands, and using artificial intelligence it can reply, and also it can detect objects using ultrasound sensor that will explain later. Then what are the features? It has locomotion. Locomotion means motion, like it has wheels so it can move. Then it has image processing capability. It can process image, so that's also a feature. Then speech synthesis and recognition. It can speak, and also it can recognize our speech. Then artificial intelligence, that I will show it later. Then obstacle avoidance. Next, we can go to the block diagram. This is the block diagram. It has motors. Then for controlling the motor, there is a motor control board. Then for controlling the motor control board, there is an Arduino, and all processing done using a Raspberry Pi. Then there is an ultrasonic sound sensor for obstacle avoidance. Then there is a camera and speaker and mic. So I will explain this part. It's very clear to you, but again I will. So first, motors. I used DC gear motor for this hardware, running on 12 volt and 60 RPM. DC gear motor means adding gears in ordinary DC motors. So it will add additional torque. It will take more load. So I use 4 DC gear motor in this robot. Then the motor control board. So for controlling motors, we need a motor control board. It will adjust the voltage across the motor using an edge bridge. Here I'm using a motor control board called Moto Mama. It is available in some online stores. The advantage is it is Arduino compatible. We can directly plug this motor driver to Arduino, and also it's using L298H bridge, that is very popular IC, and it has 2 motor out. We can connect 2 motor at a time. Then we can connect Zigbee, Bluetooth, LED, and it has LED indicators. Next is Arduino. You maybe know about Arduino, but just for beginners I'm saying it again. It's an open source hardware platform, and it has a microcontroller called Atmega 328. Then it has GPIO pins. Then it is USB compatible. 5 volt supply is giving to Arduino, and it has a very easy programming interface. So we are using Arduino for controlling the motor driver. Next is ultrasonic sound sensor. The purpose of ultrasonic sound sensor is just detecting the obstacle. So if there is an obstacle, robot will stop there. So for detection of obstacle, we are using ultrasonic sound sensor. It is also compatible with Arduino. It can detect 2 cm to 3 meter obstacles, and also TTL compatible. Then the popular Raspberry Pi. It's actually a mini computer. I think Sudhar Muthu also presented about Raspberry Pi, so it's better. I will just explain the specs. Like it has 700 megahertz processor. It has 512 MB of RAM. Then 2 USB ports. Then it has GPIO pins. Then Ethernet and audio jack. So we are using Raspberry Pi for processing. We are using Raspberry Pi as a computer here. And we are doing image processing and lot of functions inside the Raspberry Pi. I will demonstrate that later. Then the camera and speaker and mic. Camera is for getting the visual output. Then speaker and mic. We can talk to this robot. Not to this robot. I didn't do it in this robot, but the final robot has the capability to speak and recognize speech. So how it works? This is the block diagram. It will grab the frames from the camera, then it will process the frame and find the position of the ball. somehow it find the position of the ball using some image processing technique. Then if the ball is on left, then it will calculate the offset from the center of the image and send some control signal to Arduino. Then Arduino will process this control signal and it will split this control signal and find the direction, is it left or right, and how what is the offset from the center. And using this control commands, Arduino will send appropriate control signal to the motor driver. Motor driver will produce PWM and send to motors. This is a basic working. And how in the previous slide I was mentioning grabbing frames from camera and process each frame. So what is processing of frame, or what is digital image processing? So I am just giving an introduction to what is a digital image and what is digital image processing and what library I use for processing. So digital image is just like it's a representation of a visual image in terms of bits. So using these bits we can process it using a computer. So digital image processing means we are processing this digital image and finding some features using this using processing. So I am also using a digital image processing technique for finding the color. So we can do color processing using various ways. I will explain it later in the next slide. So I am using Python for image processing. I am using a library called OpenCV, Open Computer Vision. This is the introduction. OpenCV is actually developed by Intel and is now maintaining by Willow Garage and ITSYS. Willow Garage is a famous robotic research company, and it is also working on machine vision. And it is designed mainly for computer vision, real-time computer vision, and written in C++, and it has a provision for C, C++, Python and Java. So we can program in Python, Java or something. I did it in Python. Here I am demonstrating it in Python. So how this color tracking code works? Color tracking code, it will grab frame from camera, then it will smooth the frame. If there is any noise, it will smooth it. Then it will convert the current frame will be in RGB domain. RGB means red, green, blue. So it will convert to HSV, that is hue saturation value. That is for easy processing. HSV domain is like we are seeing in HSV domain. So it will be very easy to process in HSV, and after that we are thresholding that HSV image and finding the color. After finding the color, we are just finding the average of that color. Like that is called moment. Moment means the area of that color. If if I see this ball to this camera, then the moment is this much of area. Then I will find the moment and I will find the centroid of that moment, of that area. Then I will get an XY coordinate. Then using that XY coordinate, I will determine whether the ball is on left side of the image or left side or right side. Then that information is sent to the Arduino. So I will demonstrate the image processing code that is in Raspberry Pi. So this is the view from camera. So there is a center red line that indicates the center of the image. So this is a ball. So for tracking this ball, I just program, just click that ball and click the right. See. it will track. Actually, Raspberry Pi is very running on 700 megahertz, so it will take the complete CPU for processing. See, it's on left. I think the light matters. There is problem with light. See, now it's tracking. See, when it crossed the red line, it is on left. And there are some noise coming, that is because of the lighting. It's on right now. Yes, that is all about the image processing code. Then next we can check how we can send commands from this we get control signal from this image processing code, then it's sent to Arduino. So these are the commands, or these are the Python code for sending commands to Arduino. We are using Pi serial module for communicating with Arduino. Just 3 lines of code. Using 3 lines of code, we can send commands from Raspberry Pi to Arduino. This is 3 lines. First we have to import the serial module, then just initiate the serial class using the serial device and baud rate. Serial device is the serial port or COM port, communication port, and baud rate is the speed at which we are communicating with Arduino. And we can write, ser.write means we can write some value to serial port. And also we can read using ser.read function. Next, I'm just explaining how the Arduino firmware works. So we are sending the commands from Raspberry Pi to Arduino. So Arduino will receive these commands, then it will process the control signal, and it will split to the direction value and then the offset. So this is the block diagram for the Arduino firmware. First it will initiate the serial communication, then it will receive the data coming from Raspberry Pi, then it will split the direction value. If it is left, then the direction value will be L, and if it is right, then the direction value will right R. Then it will scale the offset value and it will send to the motor driver. Then it will also receive the data from ultrasonic sound sensor and stop if there is any obstacle. Then also it repeat the loop. Next it will receive the next command and it will process. Then it's just the working of ping sensor, that is the ultrasonic sound sensor. It will ultrasonic sound sensor. It has 3 pins. If we send a command to the signal pin of ultrasonic sound sensor, it will generate ultrasonic sound and it will send to the obstacle or any object. Then after that it will reflect back to the same sensor. So using that time period, we can determine how much distance is the obstacle or of the object. So that is the basic working of ping sensor. Then here we are doing image processing and also sending the values to Arduino. So I am using a communication system called ROS, Robot Operating System, for communicating this image processing code and the Arduino code. So ROS is a meta operating system. It is designed for robots mainly. It's actually doing it has functionality similar to an operating system, like it has message passing interface, low level hardware abstraction, and low level APIs to access the devices, and package management. So ROS is mainly using for robot in high-end robots, but here I am demonstrating in this robot for understanding the concept of ROS, and ROS mainly use Python for its working. There is a thing called ROSPy, so we can access all API of ROS using ROSPy. So I am using ROSPy in this robot for communicating the image processing code and the Arduino code. So there are some terms we have to understand before starting ROS. Actually, I'm starting from ROS package. ROS package is a package for a robot. I will show to you. I designed a ROS package for this ball tracking robot. See, this is a package, ball tracker, and it contains some codes for that robot. So ROS package means simply it's a package for a robot, or not for a robot, not only for robot, but for a sensor or any other hardware. And the ROS core is the master node. It's like a server. What it's doing is like it is an intermediate code between these nodes. We have two nodes, image processing node and Arduino node. So ROS core standing in the center. It will connect connects these nodes. Then next is ROS topics. ROS topics is just the messages. Like if I want to send some data to data from image processing code to Arduino code, I have to send some messages, or I have to send some data. We can use ROS topic for sending the data. ROS topic is just like we can publish some data to a name called ROS topic, and one can subscribe the same name, same topic. See, this is the diagram. One node can publish some topic, and one node can subscribe the topic. So we can exchange the data. So the intermediate code is the ROS core. So this is the communication happening. We have two nodes, Raspberry Pi node doing the tracking, image processing, and it's actually fetching image from camera, and ROS master is the intermediate code. And Raspberry Pi, what Raspberry Pi is doing is like, Raspberry Pi node is doing is like, it will send the control signal, like whether the ball is left or ball is right, and how much offset is there. That signal will publish to ROS master in some name, maybe a ball track. So if Arduino node can subscribe the ball track, it can receive the same value, and it will receive the value and process, then send to Arduino. This is a flow. So next I want to show some libraries that is used in robotics that is very interesting to you. First is speech synthesis, that is using Festival. How many of you heard about Festival? Festivals? Yeah, there is a wrapper for Festival. It is called Pi Festival. So that is there. Then next is for speech recognition. Speech recognition, actually Linux has less speech recognition tools, and it also has less accuracy. We need to train it. So there is some basic speech recognition system. We can use Pockets Phoenix and GStreamer. So combine this library, we can use it for speech recognition. I will show a demo. And also artificial intelligence. Actually using AML file. AML stands for Artificial Intelligence Markup Language, and PyAML. PyAML is the module used for handling AML files. We can generate, or we can make a basic artificial intelligence system. That I will demonstrate it. Then for making GUI for a robot, we can make a GUI for controlling it. for moving left, moving right, moving front. So we can make using that also. There is a provision for making GUI using Python. Qt plus Qt is a very famous UI interface designer software. So there is a wrapper for Qt that is called PyQt. We can make GUI for robot using PyQt. So I will demonstrate one by one. So first I will demonstrate the artificial intelligence section. So it uses Alice bot database for the artificial intelligence. So it first is loading all the AML files. Then it will ask. It will say hello. So it will reply hi there, and also voice is coming. That is done using PyFestival.
It's good to see you, Lentin.
Can you see that?
Hello there. How many times have you gone for a swim? Where have you been?
So it's just it will reply. If you enter something, it will reply like humans. That is using a fixed AML data set. We can make AML data set, and I am using Alice bot database for this demo. Then next I will show the speech recognition system. Actually that is not accurate. I have to train it before the recognition. So yes, there is a GUI. Actually it will not. Hello? No. Actually currently I am using a fixed or non-trained language model or non-trained files for this recognition. If we train using our words or our speech, then it will detect. This is another thing used for robotics. Then PyQt. So we can make see, it's a GUI. We can control robot using this GUI. See, if we press front, then it's not. Code is. So we can make some GUI using PyQt. Yes. So yeah. Then these are some projects. This was the first one was my final year project. This robot is called Robin. It's a social robot. We can communicate to this robot and it will reply. That is using this artificial intelligence. Then it has image processing capability, and then it has lips, it has eyes, eyebrows, everything. So it will move according to its expression. This was a robot when I studied in my BTech. Then next robot was that robot is called Isra. This robot was designed when I worked with Asimo Robotics. It is actually a hybrid robot. It has mobility and it has manipulation. It has 2 arms and it has image processing capability. And these 2 robots are mainly coded in Python. In first robot, I'm mainly using Python for image processing, artificial intelligence, and the communication. And next robot is mainly designed in ROS. So ROSPy is mainly used for for the processing. Then I want to show the demo. So this is the robot. I'm connecting this Ethernet port to Raspberry Pi for getting the terminal. So before starting, first we have to start the ROS core. ROS core is the intermediate program that is working between the image processing node and the Arduino node. So we first start the ROS core. That is happening Raspberry Pi. Okay. Then next we have to start the image processing node. For entering to the terminal, we can use SSH. This is a Raspberry Pi terminal. In the board tracker code, and the code is in the script folder. And first I am running Arduino script. So what it do is it just subscribe the value from the image processing node, and it will send to Arduino, and we can start the image processing node. Yeah, so first there will be some random value. So next I will show this to I think it will be better. See, it's begin to track. So if it is left, then the robot will trying to move left. It's moving. It can move because of this smooth terrain. If it is right, it will try to move here. And if it is center, it will move front. It's moving. Yes. Okay, that's all about the demo. Next reference, I got this information mainly from opencv.org, ros.com and arduino.cc. Then questions. Yeah? This one.
Hi there, right here.
Okay. Oh.
Right. So the application of your robot that you've shown right now is that it detects the ball, correct?
Yes.
So don't you think the kind of hardware that you're using and the power consumption is an amazing overkill for the application? Because if you design a custom PCB board and a simple sensor without a webcam, because the power consumption would be like what? I mean, you would be able to run this for 45 minutes max, correct?
Yes.
On full battery, maybe even not that.
Yeah.
So and so, I mean, don't you think that probably using a complete OS and everything for a robot is an overkill?
Complete?
I mean, you got a Arduino with that and a Raspberry Pi, both
Yes.
or one?
Yes.
So don't you think that's an overkill? Like,
It's not audible.
no, isn't it an overkill in the sense the hardware?
Okay. Actually,
Do you need a OS running for something
yes.
else?
Actually, we can reduce the processing by reducing the frame size. Actually, it's now running in 320 240 resolution, so it will be an overkill. Actually, if we reduce the resolution, then it will not take that much of processing.
Okay. Anyway, thank you.
Any other questions?
Hi, my doubt is regarding that Raspberry Pi device. Is Raspberry Pi device supports multitasking and multiprocessing?
Yes, of course.
So can I use for this robot as well as handling the web servers and all those kind of things?
Yes, you can.
Okay, thanks.
You said the ball is tracked by the color of the ball. So
Yeah.
what about multicolored balls?
Multicolor ball. It can track, but the processing will be heavy. Because for tracking a color, it will require some processing. If we track more than one color, the processing will be high. Then it will be an overkill.
Okay. So if you want to expand it to irregular objects, how are you going to manage with this Android thing?
Yeah, for irregular object, there is a method called hard class training. It's like we can train the objects and we can make a XML file. So using that XML file, we can detect that object. So there is also a training for irregular objects.
Hey Lentin, nice talk. The question that I had was, I noticed that during a demo, you kind of clicked on the image of that ball.
Yeah.
So is it like you actually need to calibrate it a bit so that the robot knows what needs to be tracked, or is there a way to automate that thing?
Can you?
See, when you were showing the demo, right, you actually
Yes.
clicked on the ball, as in it said like right button click or left button click. Is it like a calibration kind of thing for the robot to kind of tell it like this is what needs to be tracked? And if that is so, can that be automated? As in, if we just keep the ball in front of the camera,
Yes.
does the robot know that this is the object which needs to be tracked?
Yeah, actually, what actually doing is like, if the ball is on left side, then it will move to that ball. It will track it. It's only tracking, and it track like if the ball is on left, it will calculate the offset, how much distance from the center. Then I will scale that value and move that much to the left.
And one more question: the frameworks or the packages that you mentioned for speech recognition, like GStreamer and Pocket Springs,
Yes.
are there any other alternatives like other than
Yes,
these?
there are
Like,
some other alternatives. There are Julius. Julius is there, but I don't know whether there is any Python module.
there's something called Spy Speech and also Dragonfly.
Yeah, PySpeech is there, but that is in Windows. I have already used that, but that uses Microsoft Speech Recognition SDK.
Okay.
Yeah, that will work fine. That I use for my robotic project. That will work well.
Okay. Thank you.
But in Linux, there is no other.
Yeah, thank you.
Thanks. You.
Hi, the same thing can be done using MATLAB and Arduino. What is the advantage of using Raspberry Pi over here?
Yeah, actually, you can use MATLAB for it, but you need to use PC, right?
Over here also you have connected it to PC, right?
No, actually, now I just use PC for initiating the programs. Maybe I can automate it.
Okay, so you mean to say you can patch it completely?
Yeah.
Fine. Thank you.
It's rather a suggestion than an actual question, but when you're using that audio recognition,
Yeah.
we were just trying to get what the speaker is saying, right?
Yeah.
So you can actually use the request module and you can send a request. It's a hacky method to what Google does for their
Yeah,
webkit
that is
audio.
also there.
It's a very, it's a very solid.
We are using that. We are using
stable
that.
one.
But the dependency is internet.
The
I
dependency
can't.
is
I can't
Google.
use for in offline.
True.
That is. It will work fine.
Any other questions?
Last question. Okay. 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 This is the last question.
Sound right? Yeah. You were talking about nodes.
Okay.
Correct me if I'm wrong. So you said there is a Raspberry Pi node, there is a Arduino node,
Yeah.
and you use ROS to kind of
Communicate.
communicate between them.
Yes.
Are there three things you are running? Well, you run a Python script for Raspberry Pi, you run a Python script for Arduino, and you run a third thing for ROS, is it? Or you have included the ROS things in the individual nodes?
Actually, this ROS and Raspberry Pi node and Arduino node are all running on Raspberry Pi.
Correct.
Okay.
Yeah.
So ROS is for communicating.
Yeah.
So we are starting a Raspberry Pi node. That is also Raspberry Pi node and also Arduino node.
Okay.
Then we are starting. Then we are using ROS framework to communicate. That's all. All in Python. All in Python.
Okay.
Okay.
Thank you, Lentin, for the good talk.
Okay. Thank you.